In previous chapters, we have discussed several features of the components that make up a laser. These are the laser medium self, whose interaction with an electromagnetic wave was considered in chapters 2 and 3. The passive optical resonator, chapter 5, and the pumping system, chapter 6. And this chapter we will make use of results from this earlier chapters to develop the theoretical background required to describe the continuous wave in a classical wave laser behavior. The case of transit laser behavior will be considered in the next chapter. The theory developed here uses the so-called rate equation approximation, and the laser equations are derived on the basis of a simple notation that there should be balance between the total atoms undergoing transition and total number of photons which are being created or annihilated. This theory has the advantage of providing a rather simple and intuitive picture of laser behavior. Furthermore, it gives sufficiently accurate results for most practical purposes. For a more refined treatment, one should use either the semi-classical approach, in which the matter is quantized while the electromagnetic radiation is treated classically, that is, through Maxwell's equations, or the full quantum electrodynamic approach, in which both matter and radiation are quantized. We refer the reader elsewhere for these more advanced treatments. Rate equations. We will consider the rate equations for both 4-level laser and quasi 3-level laser, where the lower laser level is sub-level of the ground state. These two categories of laser include, in fact, the most important lasers currently in use. In the category of 4-level lasers, one could mention, for instance, ionic crystal lasers such as neodymium lasers and various hosts for most of its many possible transitions. Chromium and titanium doped lasers, with the exception of Rabi, chromium plus 3, aluminum oxide, the first laser to operate, which involves a pure 3-level scheme. Gas lasers such as carbon dioxide, helium-9, helium-selenium, earth ions in various crystal or glass hosts such as YB, ER, and YB, ER, HO, TM and TMHO, and for its shortest wavelength transition ND again. For level laser, we will consider an idealized four-level scheme in which we assume that there is only one pump level.